Okay, in this video we are going to explore the use of timers. So we're going to set the scenario in that we're going to press the SWG button and we want that to control the conveyor for a given length of time. So effectively what we want is the switch screen button to control the conveyor to run, and we want it to run for a certain length of time. So we need something in between here to do that. Now, the simplest and easiest way to achieve this is via a timer, and there's two main timers we're going to look at. The easiest one to achieve is what's called a TP or timer pulse. So insert it in, let it name itself, accept all the options, and then set our timer for say 3 seconds for the purpose of the demo. Keeping in mind, timers left hand side need fill in, right hand side don't necessarily have to have anything filled in. So this ET, you don't have to touch that, you can leave it alone. So the input to this is going to be SWG. If you get a rise of input into in, it will then run this pulse timer for 3 seconds, no matter how long SWG was on for. As long as it's picked up within 1 scan cycle or it's held on forever, the output Q, which will drive the E, enable for the conveyor, will be on for PT amount of time, or in our case, 3 seconds. So very simply, in layman's terms, activate SWG, this timer will turn that output on for 3 seconds only. So we'll just download that, we'll make sure everyone's happy with the understanding, and then we'll look at why that may not be the best option as well. So we'll download that in, hit load, and we can now go online, and we see it's currently active. Now we can obviously press the actual button here behind us, you see it becomes active, and then for 3 seconds worth that output turns on. So we'll just let you see it visually here as well. We press SWG, the light comes on for E and stays on for 3 seconds worth. Whether I press it for a short period of time, you still get 3 seconds, or I press and hold it by using the detent option. So I've pressed and held SWG, as you can see in the background here, but E has only still stayed on for 3 seconds worth. And then I have to turn it off again and then back on before I get the output again. So that's one option. It's not always the best option that we want at times, and sometimes what we want is a ton timer. So if I alter this, we go offline first of all, and to change this to a ton timer. Right. Now that's going to be 3 seconds worth. So just to show the such issue that we're going to have here, we'll re-download because we made a change. Press load, and again I'll go online with monitor mode. So I can put this to one side, give the video to the other, and I can see that if I press that, this is now creating an on delay, which is slightly different. So previously what I had is when an input came on, which is SWG, I got the output for 3 seconds amount of time, which is maybe what you want to achieve. The other timer here is a ton timer or an on delay timer. It will give you the output once the PT, or in our case 3 seconds, has actually occurred. So I need to press and hold my input SWG for 3 seconds amount of time before the output turns on. Now the difference is with this one, the output will stay on until you lose the input SWG. So I have to press the button again to lose that, and now it goes off. Now sometimes what you want is an output to turn on after a delay, but the problem is that the SWG in this instance might only be pressed for a short time, so pressed and released, and it doesn't then trigger. So what you can do in that instance is effectively latch or keep on that SWG. And the easiest way to do that is to put in an SR flip-flop. So we put in an SR flip-flop, we just give it with a tag address here. So if you press the SWG at any point, it sets that SR flip-flop, which will give you a permanent cue coming into that timer. You will then get a 3 second delay, and then that will run. Now in our example, what might happen is the part travels down and then activates one of the sensors, let's say S3. So while, or S1 rather, So we put in S1 in here. Now the only thing that we need to watch is that we need a normally closed of that one because of the way the logic operates. So the format here to get E to come on after a time delay. So we press the button, it latches on via the SR, gives you a permanent Q here. This bit generates the time delay, in this case for 3 seconds. After the 3 seconds, E turns on. The part would transverse down the conveyor, and when it passes the S1 sensor, that would go off, triggering a reset. Therefore, Q goes off, you lose the timer, and then Q 0.0 or E will then go off. So I can download this, update the bits as required, back onto here, and then we're able to, and let's just get the camera up at the same time. So I can press my SWG, I let go, you see that the SR's latched, I get a delay here, then E turns on, as you can see in the camera, and then as the part travels down, eventually it goes and arrives at S1, passes by that, so the part went through the sensor at this point, therefore triggered that to go off, and as you see, it's triggered the SR flip-flop to a reset condition, and is now turned that off. So if you now lift the part away, that would effectively go back to being on, and it means you can now press the button over again for SWG, and you can let go, 3 second delay, the output turns on, it transverses down, and then eventually arrives at S1 and turns itself off. So that's a method of getting in this case, conveyor to turn on after a delay, travel down the conveyor, and then turn off via one of the sensors.